Hi everyone, welcome back. This is Raju from Smart AI Technologies. Today I am going to demonstrate you a project called Diabetic Retinopathy Detection using deep learning. As you can see, this is the final web application after doing so much of pre-processing, cleaning, model building, training, validation, testing, and then we integrated it into a complete web application. And then here, if you upload any diabetic retinopathy images, you could able to detect what is the condition of the diabetic retinopathy, that is mild or severe. Based on that, what is the cause and what is the possible treatment for that diabetic retinopathy. And you can see here the region of interest is being detected and it is being highlighted. First of all, you need to understand what is this diabetic retinopathy. So diabetic retinopathy is in two cases. The first case is that we'll be having some blood lines here, blood vessels here. So in first kind of diabetic retinopathy, the blood vessels will bulge in size. Okay, they will their size will increase and they will rupture and blood will come out of that. That is one kind of diabetic retinopathy. Another kind is actually we will be having so many blood vessels in our eyes. So sometimes what will happen, those blood vessels will give birth to new blood vessels randomly. Okay, it will not follow the pattern. Some random new blood vessels will grow out of that. So that condition also diabetic retinopathy. Okay, now here what you can see here in this demonstration is that here one image, these are the new lines, these new lines are being growing. So that's why this is a mild stage. Severe stage is also there. This is the complete web application that we built after doing so much of pre-processing, analysis and everything. But before that, how we planned, how we built it, because if you are taking this for a research, you need what is uniqueness in your project. It is not only like you code something and you present it. You should be reasonable what you are doing and how we are doing. So for that purpose, we follow steps like this. First, we'll take up few IEEE papers. We go through the IEEE papers and we study their methodology and we take out what they done in their work. That is existing system. Once we get an existing system, we gonna propose our own methodology which is better than the existing system. And then that proposed methodology will be taken and according to proposed methodology we will build the project. And then the built model, after the proposed methodology, the built model will be integrated into this web application. So let us now start to discuss some IEEE papers and we'll try to check the existing system and we'll try to see the research gap that we have so that we can fill that research gap with our idea, okay, and to make our own proposed methodology. So we are using diabetic retinopathy dataset. Okay, this is one of the best dataset available and these are all the different models. I will discuss about those models and what accuracies we are getting. And one thing, why I'm saying like our proposed methodology is best and how I am saying my proposed methodology is best, because we are getting far good result than what the previous papers were getting. One sample result I will show you. Can you see this? More than 96% of validation accuracy and training accuracy is almost 99.58. So like this we are getting too much good result. We are getting too good result. And one, I'll be discussing these technical stuffs. Okay, so what we are using, I'll theoretically mention it. Okay, we can't provide codes here. If you want complete code, documentation, support, you need to reach to us. Okay, you can contact us through WhatsApp or you can directly call to us or you can directly visit to us if you are from Bangalore. We are Smart AI Technologies. We located in Bangalore, Vijayanagar. You can visit us and even you can take our offline support also. First, we'll go through two papers. This is the first paper named as Diabetic Retinopathy Detection Using Machine Learning and Texture Features. So this paper mainly discussing how to use texture of the retinopathy image to classify using machine learning. They are not using deep learning. They are using machine learning as a model. So you can see here, we made a note. Okay, what are the existing system of each paper and what data set they are using. So this is the existing system of the present papers. Okay, the first paper that I am showing, okay, that is this paper. So in this paper, you just scroll down to the methodology section, proposed approach, and you will see what dataset they are using. Okay, they are using Messidor dataset, and then okay, under pre-processing, what they are using, how they are extracting the features. They are using two techniques called LES and RBF. They call it as a local ternary pattern. Okay, using LTP technique, they are using LES and RBF to highlight the blood vessels. To keep it very simple, they are highlighting those features here in the case the blood vessels in the image. They are using ALEF and RBF. Now, as a machine learning model, if you open this here, as a machine learning model, they are using I think SVM. They are using support vector machine as a machine learning model that you can see here. They will be mentioning that. They are using SVM as a model, and what accuracy they are getting? Actually, with okay, the accuracy they are getting is actually 90.4 with LESH as a feature extraction plus SVM as a model. 90.4. This will be testing accuracy, I think, and then they are using RBF with again SVM. Now they are getting 93.1. These two different accuracies they are getting, and they are mentioning here in combination. You can see that I think 93.1, 90.4, and all these graphs. Okay, so this paper mainly providing us the existing system of that paper is this much. Dataset is this, and they are not doing much in the pre-processing part. They are not mentioning in depth what they are doing. It means they are not taking up any particular filters, any combination of pre-processing techniques. Okay, and then so this documentation we can give you as a synopsis if you approach us. So once you read this synopsis, okay, and if you want, we can attach it in the website and we can provide you the link also. Better you can approach us through WhatsApp so that we can share this synopsis. Just go through the synopsis. Anyway, I am discussing the same thing with you now. And from this, what limitations are there? First of all, like this project should be done with the help of deep learning. Okay, and when there are images, you should not try to extract feature one by one. For machine learning needs like that only. Features need to be extracted separately. But if you take deep learning is one of the best techniques for image based work, because in deep learning each and every pixel of an image is actually a feature. In machine learning it won't happen like that. You need manual extraction of the features. So that is a drawback. That's why their accuracy is very less, that you can see there already. And the second IEEE paper that we got is Diabetic Retinopathy Detection Using Deep Learning. Almost this title is almost same, but the authors are different. Okay. In this paper, these people are mainly concentrating on image augmentation. Okay. This image augmentation can be used for multiple purposes. Particularly this paper using image augmentation only to overcome the overfit underfit issue. Okay, they are inducing some noise during the training, that's all. And they are, again, this paper is using CNN architecture, deep learning model, but they are using custom CNN model. This is a drawback. In CNN there are two types. One is transfer learning and another one is custom CNN model. They are using custom CNN. It means they are building layers one by one themselves. The problem with building custom CNN is that you can't build a efficient model. The model that you think will work better will not be that much good. It will take a lot of time. Drawback of, you just see, I'll give one example. Okay, what is transfer learning and what is custom CNN? I think you will understand this example. Let us take, there are two people, A and B. Now this A person who don't know anything about martial art, he don't know, is nothing. Okay, is zero in that. Whereas this person knows karate. This person knows nothing, this person knows karate. Now I will give one one task to you. Just train both of them for kung fu. Kung fu. Yeah, I will ask you to train both of them for kung fu within a week. My time is limited. I want better result. Who will be doing this task faster? B will automatically be learning better and faster than A. A will take more time consuming, and sometimes he may not learn better if your layers are not structured well. Both the problems are there. So now B is like a transfer learning model. He's transferring his old information. Maybe the old information was not exactly for kung fu, it was for karate, but he can transform that training thing and he can train for kung fu very easily, so that he can yield better result. In our case also, normal CNNs are like this. Okay, whereas transfer learnings are actually CNNs which are already trained on some XYZ. They are trained on dog, cat, table, chair, books, sofa, TV, but they are not trained on diabetic retinopathy images. Now we will call them here, we will manipulate them and we will train them for our diabetic retinopathy. They will learn faster and better. Okay, these things we call them as a transfer learning model. So always transfer learning models will take upper hand over the custom CNN architecture. So that only mentioned here almost. Okay, now after going through both the papers, you can check those things. Okay, the things will be almost same. Okay, whatever I told you now, those things are extracted from this paper itself, the second paper itself, whatever the paper that you are seeing here. Even they are mentioning here CNN design, they are designing their own custom. They are using augmentation, but they are using only to induce noise to overcome overfit or underfit issue. Actually you can see their accuracies. Okay, their maximum accuracy is 94%. Okay, and they used few more models. I don't think they didn't mention before which model they are using, but into their table they are saying VGG 1973, DenseNet 2181 and SVM 87. Okay, so that they are mentioning these are very less, so the sequential model is more according to them. But in our case we are getting more than 96, 97, nearly. Even I will show you two other models in detail. I will show you what are the models I am using, how much we are getting now. So this is a way to decide what to do based on existing system, based on technical existing system. You need to define the technical proposed system. Then anyway, when we build a web application, there we can add n number of features. Yeah, some people will be looking for that. They want more features on the website, more things that is visible for the lecturers. They want graphs to be displayed on the website. They want analytical things to be displayed on the website. That can be done. The most important thing is you need to be strong in this technical part if you want to prove that yours is better than the existing. Okay, after going through these two, actually this is a confidence score. This is not accuracy. Okay, these things are confidence scores. Okay. Now after going through both the papers, whatever the things that I am defining, that I mentioned in this document, which I will share you if you just messages through WhatsApp. You can take this. You can take this and you can use this. Okay. So in our proposed thing, first we are handling the data balancing. Okay, this is one of the biggest problem everyone neglecting. So the data set, the images we have will not be balanced almost, even though there will be some difference. Like one class will be having 1000 images, another one will be 200, another one will be 800, another one will be 400. How this is most important step that I will tell you with the diagram. Now if you see here, for example, let us take let us take here, there is a one box with 1000 apples. Okay, another box with 10 tomatoes, 10 tomato, 1000 apple. Now there is a small boy, okay, who don't know about apple and tomato. Let us take he don't know anything. Now I will ask you to train him. What you will do? You will take one apple, you will train him this is apple. You will take one tomato, you will say this is a tomato. Like that, after 10 times your tomato will go away because all of them you trained. Now after the tomato you will train 990 apples. So maybe initial this 10 finishing you trained for 2 minutes, but after this 990 you trained for 2 hours, let us take. So this boy, after the complete training, will he remember whether you trained for tomato? Because you are training him for first time. He will not remember even you trained for tomato. Okay. So whatever you show, you will say you trained for apple. Just everything is apple. This is the same thing that happens with our models. Images should be well balanced. Okay. So then only you can train the models for a good accuracies. So you can't neglect the imbalanced data set thing. So in our case, we are going to balance the data set using augmentation. Technically, I'm not going to reveal the remaining steps, how I am doing, what are things I'm using. Okay, but we are going to balance it. And then under the pre-processing, no one is taking care of the pre-processing stuff. The paper one has tried little bit to take LSF like that. That also they are extracting the feature. Okay, but make that better, make that image better first, because it will be having some noise within it. If you take features as it is from the noise image, I don't think that will be a good idea. First of all, clean the image, pre-process the image. Okay, so here what we do is we apply steps one by one: cleaning, pre-processing, okay, removing the noise, okay, enhance the image. For all of them we have particular step. For everything we have particular step one by one. And after that we call it a region of interest highlighting, or uh, image segmentation, or highlighting the what do you say, main feature or important feature of the image, like this. So for that we are using some filters, some combination of filters. Okay, I'm not going to reveal the exact technique here, but if you approach me, if you discuss once with us, with our team, okay, we will be providing you in detail synopsis, okay, what we are doing. So then you can decide, okay, whether you want to take the service from us or not, okay. Then you'll understand, okay, whatever we are doing, okay, in detail things we will be providing you. Once you take our service now, I don't think you'll feel like anything like you are getting confused or like that, because we'll be setting one-on-one sessions. We'll be setting up Google Meets, Zoom, Teams, or if you want to come offline, you can come offline, okay. We are Smart AI Technologies located in Vijayanagar, Bangalore, okay. Even you can come offline also. Okay, after this, after pre-processing, cleaning everything, our images will be with high quality, with a well region of interest highlighted, okay, with less noise, because we are using noise removal filters, okay, and then edges detected. So our images will be now completely improved version. After that, okay, so here I'm trying to mention those techniques there. Okay, so if you can see there, here I'm trying to mention few techniques here, image processing, whatever things I am doing, but in combination I am doing, okay. Model architecture, in model architecture we are trying to go with first two transfer learning models. One is EfficientNet and another one is MobileNet separately. And then what I am trying to do is, I am trying to combine both of them to create a hybrid transfer learning model, which will be lot complex than two separate models. And again, one thing you should remember, when you are combining two very complex models, your dataset should be very huge, okay. But always hybrid model will try to give good result. You need to train it for a long time, okay. So three different transfer learning models we are trying. And remember one thing, if you already have something in your mind, like I don't want to use MobileNet, I want to use XYZ another model, like that, and this, you can come up with that also to us, okay? You can just mention us what you need, which model you need, what kind of implementation you need. According to that also we'll build. So here you can see, first we took the data set, okay, and we balanced it. This code is actually balancing. I told you now, we gonna apply augmentation to balance the number of data sets. So after that, the number of images for our data set is like this: 1000 images, 2000, 2000, 5000. You can just create, okay, generate number of images, balance it, okay, to balance to the equal number. After balancing, here only I told you we are going to apply combination of filters. By applying combination of filters, even though this is 3D like images, the regions are highlighted with red colors. The lines, the visible lines are highlighted with the red colors. And after that, we gonna split our data sets, and then we gonna build our model. This is first model. This is our MobileNet EfficientNet. Sorry, this is our MobileNet EfficientNet hybrid model. Okay, so this is giving around 90%, I think. 91% test accuracy is 91%. Classification report you see, okay, precision, recall, F1 support, everything is here. Precision, recall, F1 support of the classification report, okay. Everything, every result is being displayed before your eyes, okay. Here nothing will be done in the backend XYZ, okay. We show what we did, okay. Even we do what you mention also. And then this is most important thing that we are doing. No paper discuss about it. What is that? I'll tell you. That is explainable AI. What is explainable AI? I will tell you. For example, this is diabetic retinopathy image. Like this, it will be eyes, okay, and the lines will grow like this. Lines, blood vessels, like this. It will be. Okay, I'm not good in drawing. Now, when my model is well trained, finally I will ask my model to predict whether the particular diabetic retinopathy image was severe, whether it was mild, whether it was no diabetic retinopathy. So it will say something, okay, it will say mild. Okay, now this normally, like all the paper presented, they will build the model, they will implement. Now I am mentioning explainable AI. What is explainable AI? Is if my model says this is mild diabetic retinopathy, explainable AI will try to give me visually which region of this diabetic retinopathy was more impactful, which was more impactful, whether this region was more impactful, whether this region was more impactful, which region was more impactful to say that this was mild. It doesn't mean like remaining area is not important, but which area mainly impacted a lot. It will try to explain how what part of image made the prediction better. So explainable AI will always increase the results efficiency. So this explainable AI, okay, XAI normally, like we say explainable AI, that explainable AI also we implemented. You can see here the more red, that impacted a lot. Okay, and then another model with us is actually EfficientNet alone. Okay, EfficientNet is net alone is doing a lot better, 97.40, which I mentioned even in that document. Okay, and explainable AI here is very clear again, which area, how it is impacting. And as I mentioned, my third model is MobileNet alone. MobileNet alone. So this MobileNet alone is again doing great. This is also going more than, training accuracy is more than 99. Training accuracy of our models are more than 99, and as well as testing accuracy, validation accuracy is more than 90, and testing accuracy is 93.40. So for every model we will be getting training accuracy, testing accuracy, as well as validation accuracies. You need to see all of them. Okay, yeah, when you take up our training models, training accuracies, all of them are more than 90, almost 99, 98, more than 98. Actually some papers will try to present the training accuracy only as accuracy in their papers. Sometimes they won't mention the testing and validation accuracies. You should keep that in your mind. You should be very careful, and you should present mainly testing, training and validation, three of them in the papers or the presentation. Okay, in the presentation. So after building three models, we are going to save these models, and here also explainable AI again come into act. And here it is saying this area is the most impactful area. Remaining area is impactful, but this area was the most impactful to classify this image as some XYZ, mild, severe, no diabetic retinopathy. Now after doing this, we are going to build a web application with HTML, CSS, JavaScript, and mainly Flask as the backend. Okay, so like this you can see the code. And then this is our best model, diabetic retinopathy.h5, which we train in Jupyter Notebook, will be loaded here, and it will be implemented. Can you see here? Mild, moderate, no diabetic retinopathy, proliferate diabetic retinopathy, and severe diabetic retinopathy. So here we are loading the model which we trained in the Jupyter Notebook. Many students, they will try themselves all the things. Sometime they can't, they will not know how to integrate that. Sometimes they will be having this problem also. So this problem we can solve it. So even if you are trying to build some model, if you need only front end support also, you can approach us. You can approach us for any phase of the project. Whether you want us to only to build a model, you can build the model. Sometimes for some projects we will give entire project, we will not work on phases, middle phases. Okay, so remember that. Okay, it doesn't mean like we'll give you that for all the models, no. Okay, and then here we load the model, we integrate that into web application, and then when you upload something on a web application, give the result. So here you see finally how it looks like. This is our complete web application after we integrate that front and back and everything. We have so many HTML files, CSS, JavaScript, okay, and then finally it looks like this. And when you click here, it will ask to upload our diabetic retinopathy images. So you can just upload, and you can check, cross verify whether it is giving right or wrong. You can try it on multiple number of images. You can take and you can upload n number of images, and as we are mentioning, our accuracy is more than 97%. Almost you will get right answers for all the images that you upload. Okay, again if you want to see the demo also, you can just approach us, message us in WhatsApp. We provide you a schedule, and that schedule we provide you the free demo. You see the demo. If you want to see the demo after watching the video, if you have any question, ask there. Okay, you can just give a testing images. We let us test before your eyes from that data set. Okay, so this was all about the diabetic retinopathy project. If you have any queries, any questions, or anything that you need, any kind of support you need in these projects, please approach us to the given number below. You can just WhatsApp us directly, call us, or you can just visit to our office, or you can text us through our website. Like that, we have so many connections. Okay, you can come on LinkedIn, you can come on Insta, Facebook. Okay, you can visit, you can reach us through any form of social media like that. Okay, thank you very much for watching the video, and don't forget to subscribe, like, and don't forget to forward this to the people who are in need, maybe your friends, okay, maybe your juniors, so whoever it is. Okay, you can just guide them to this good project, because if you work once with us, you will understand the things very clearly. Okay, thank you very much for that, for the time. Okay, we'll see in the next video. Bye then.